ChemWiz is an interactive information visualization system that enables users to gather insights on chemical compounds and their chemical properties and helps in understanding the evolving nature of these chemical compounds. Like an alchemist turns base metals into gold, our visualization system turns raw data into useful information, which is like gold for data analysts. The system consists of 4 types of visualizations, each of which provides specific insights into the dataset. Let's look at our first visualization, CineChem. CineChem leverages the storytelling technique to narrate the behavior of groups of chemical compounds with respect to 4 variables, namely the boiling point on the x-axis, solubility on the y-axis, melting point in the radius of the bubble, and toxicity by color. Since there is a correlation between solubility and boiling point for compounds, we have used those on the axes. Using CineChem, we can visualize intergroup and intragroup trends like similar correlation patterns. For example, the acids and bases have their plots all over the place, which indicates their non-linear variation, whereas a group like nitrates has more of a linear variation. Spotting outliers also becomes pre-attentive in some cases, like the abnormally high melting point of sodium hydroxide or the anomalous solubility of hydrochloric acid at room temperature. Next, we shall look at the box plot. The box plot view leverages the small multiples principle as advocated by Edward Tufte, wherein the user sees a trellis view with box plots for each of the properties of the compounds. Think of this as a workspace in which the user can drag around the individual plots and get better comparison between any 2 properties across groups. The user can also choose to draw intra-group insights, such as comparing just the nitrites across multiple properties. Resizing of plots allows to zoom into specific plots and also get rid of others. Further, following Dr. Schneiderman's overview zoom and filter mantra, the user can click on any plot to get details such as the 5-number summary for each group of compounds and derive further insights. In the case of toxicity, if the range of values for this property is large, it means that the compounds in this group show a varying trend of highly toxic to non-toxic. This can be seen in case of the bases. But if the range is small and low, it means that most of the compounds in this group are highly toxic, as can be seen for the acids, the chlorides, and the nitrates. The user can further switch between these detailed views for each of the properties. Next, we shall look at the sunburst technique. Since there lies an inherent hierarchy when it comes to chemical compounds, the sunburst viz is an ideal medium to portray this hierarchy. This viz provides an overview and detail at the same time. It encodes 2 variables, namely the color indicates the group and the area of the sector indicates the value of the property such as the boiling point or the melting point. Details can be viewed by hovering over a compound. Initially, all compounds have equal areas since no property is selected. Once a property is selected, the sunburst filters out to show only those compounds whose selected property value is greater than the value on the temperature control slider. Since area encodes the boiling point in this case, we can conclude that acids have low boiling points in comparison to salts and bases since they cover a very small portion of the circle. This can be corroborated further by increasing the boiling point to see that all the acids have boiling points and melting points below 350 degrees Celsius, which means that they would move into the gaseous state at this temperature. As the melting point increases further, we see that the salts remain visible, meaning there are salts in solid state even at such high temperatures. This viz has the potential of drawing further insights by experts in this field. Unlike the previous visualizations, this viz is made from ground up without help of any external visualization library. We believe that this viz is ideal for anyone looking to find insights that cannot be predetermined, and it can be used as a teaching tool for a chemistry fundamentals class. This chemical lab setup allows users to add compounds to the beaker and then control the temperature and pressure knobs to see changes in their physical state or phase, that is the solids, liquids or gases. The color and position of the bubble both indicate the state of the compound, red meaning solids, green for liquids and blue for gases, though the positions make this almost pre-attentive to understand. The radius of the bubble encodes the solubility. The setup is initially at standard temperature pressure which is the universal baseline for chemical experiments. On increasing the temperature, the compounds rise or fall depending on their boiling or melting point. The speed of their rise or fall is governed by yet another variable, that is their molecular weight, which is again pre-attentive. The heavier they are, the slower they move. Gathering insights is up to the user depending on what combination of pressure and temperature is tried out. It can be seen for sodium nitrate that with constant temperature but change in pressure, it changes to liquid. This is because increase in pressure causes increase in the boiling point, hence it moves into the liquid state.